Hi, I'm Chris Bolgiano, and I really appreciate this opportunity to talk about our globally unique Appalachian forests and their significant role in the global climate commons. My presentation today is based on two Appalachian undertold stories, which converge into a path toward repair of the past and defense of the future. I started learning about these temperate, deciduous woodlands when my husband and I moved, quote-unquote, back to the land on 112 wooded acres on Cross Mountain in western Virginia in 1982. Our long back border adjoins the 1.2 million acre George Washington National Forest, so from the beginning we straddled the physical and the philosophical line between public land and private land. It may not look like it, but at the time, I was the Rare Books and Manuscripts librarian at James Madison University in Harrisonburg, Virginia, which involved collecting local Shenandoah Valley history. This is by way of disclosure that I'm not a professional forester. I'm just a tree-hugging retired librarian with access to a whole universe of data. My first undertold story is not the fact of the widespread deforestation of the mountains, which is well documented, but its legacies in the woods. As we got lost on Cross Mountain, we noticed many multiple-stemmed chestnut oaks. This is because chestnut oak bark is high in tannic acid, which was used for tanning leather. A tannery was often the very first business established in a new settlement. By the mid-1800s, millions of tons of bark were being peeled every spring until the 1940s, when chemicals replaced it. The naked trees were often left lying in the woods, where they contributed to widespread fires. Unlike most hardwoods, chestnut oaks sprout readily from stumps, and deer had been hunted to near extinction by the early 1900s, so the sprouts escaped browsing. My husband likes them for a hunting stand. They're comfortable in the middle, and they have a backrest. This iron furnace is not on my property, but it's not far away. Thousands more furnaces stand along the seams of iron ore that run down the mountains just west of the Blue Ridge. They were all fueled by charcoal, which burns much hotter than wood. Charcoal hearths were mounds of 4-foot logs smothered with soil and smoldered without oxygen rather than burned. A typical furnace would consume at least 150 acres of trees, clear-cut annually. After 25 to 30 years, the trees were cut again. Millions of forested acres were repeatedly clear-cut for charcoal until the 1920s, when northern furnaces outcompeted them by using cheaper coke made from coal. You might imagine that charcoal hearths also have contributed to fires in the woods. This is a home-welded boomer, or winch, that stands on our property like some kind of modern art sculpture to memorialize the deforestation. It was probably made in the early to mid-1900s to pull logs from steep slopes and down in the hollows up to the ridge, where a horse or oxen-pulled cart, or later a truck, would carry them to the nearest mill, or later a railroad depot. After the Civil War, as southern cities rebuilt and northern cities expanded, the small-scale railroads called dinkies crawled up almost every mountain run of any size. Lower, more accessible forests had of course been cut over many times, but there was still mostly virgin timber on the steepest slopes and highest ridges. And what grand timber it was, many centuries old. You can see that the poplar log on the left filled several train cars. Below it, the white oak stump where the family is sitting measured 13 feet in diameter and is believed to have been over 1,000 years old. So what happened was the biggest logging frenzy in world history, from about 1880 to 1930. In that half-century, West Virginia went from being 95% forested to 85% denuded, and that's more or less what happened down the entire mountain chain and across the east, where only an estimated 1% of the original forest survived. The equipment of the day was steam-powered by wood or coal and threw lots of flaming embers out into all the tops and limbs left behind on the ground. So, more fires. And we find lots of old fire sign in our woods. With no plant roots to absorb rain, millions of tons of soil were carried away by almost every rain, soil that had been developing for thousands of years. That is the ultimate and most consequential legacy of deforestation. Where did all that dirt go? That is the first undertold story. Much of the eroded soil was initially impounded behind many thousands of mill dams, but when water milling ended in the 20th century, the abandoned dams failed, and the sediment began moving downstream. It's still moving. Called legacy sediment, it's a widespread consequence of upland erosion that is now clogging valley bottoms across the southeast. A North Carolina scientist recently declared that legacy sediment, quote, would remain a water quality problem for centuries, end quote. In 2018, researchers at the Water Science Institute in Pennsylvania wrote that eroded soils are, quote, typically 2 to 14 feet thick along valley bottoms in the Mid-Atlantic region. Archaeologist Carol Nash of James Madison University told me that she commonly digs through 3 feet of soil along the South Fork of the Shenandoah River deposited from logging in the mountains before she even gets to earlier levels of European settlement. And below that, just 1 inch represents 1,000 years of Native American impact. Soil is the basis of all fertility. To understand just how much the forest can change after such serious abuse, contrast this original red spruce forest in West Virginia, which once covered many hundreds of thousands of acres, with the spindly oaks and monoculture ferns in that same area today. I've heard people say in ferny glades like this, "Oh, how beautiful, how primeval." But in fact, these are the only plants that will grow here a full century after this area was logged, burned, and grazed. While decades of regrowth now mask the reduced fertility from soil loss, in 1943, a forester's report on the Virginia mountains noted that even some of the better growing sites, quote, because of fire or other past abuses, are of low productivity, end quote. It will take centuries of leaf fall, root growth, and protection from soil disturbance to recover some portion of that lost fertility. And there's another loss that is just as fundamental to soil productivity and to our future, and that is soil carbon. Soil is the pivot point, the most intimate ecological connection between the past and the future. In forest soil is where our future lies. And here's why. Not only is soil the source of fertility for everything that grows, it's also the largest reservoir of carbon on land, and most abundantly in forest soil. Tree leaves take in carbon dioxide, the major greenhouse gas, from the air during photosynthesis, and gives off pure oxygen for our breathing pleasure. At night, leaves give off carbon dioxide during respiration. When leaves take in more than they give off, which is common, excess carbon molecules build the wood in tree trunks, limbs, and roots. A tree is about 50% carbon. From roots and from decaying leaves and fallen wood on the surface, complex carbon molecules seep down into the soil. Consider this. Forests in the lower 48 states sequester roughly 13% of America's total carbon dioxide emissions every year. The amount of carbon already stored in U.S. forests is equal to at least 67 years of fossil fuel emissions at today's rate of combustion. And most of that carbon is in the soil of eastern forests. Trees are the best technology yet discovered for carbon capture and storage. Several scientific papers in the recent past have pointed out that natural climate solutions can provide more than a third of the necessary climate mitigation needed by 2030, and much of that mitigation can be achieved by protecting existing forests so that they continue to grow. But the devil is in the underbrush, and while any forest is better than no forest, it's not just any old pine plantation that can sequester more carbon than any other place on Earth. It all depends on how a forest is managed. Foresters used to think that when trees get older like this one, their growth slowed and they stopped sequestering carbon. Therefore, they should be cut to let young trees grow. That belief was based on very little field evidence, and in 2009, an international team of editors completely overturned it. That is my second undertold story. After analyzing hundreds of studies around the world, the editors concluded unequivocally that mature and old forests continue to sequester and store carbon as strongly as younger forests for as long as they live. For our native oak, hickory, hemlock, and other tree species, that could be 600 years and more. Dendrologist Dr. Stockton Maxwell of Radford University recently documented 700-year-old red cedars on a remote cliff in West Virginia. Around the world, there are so few forests older than 600 years that researchers couldn't research beyond that age. And our eastern forests in particular were validated in 2018 by this book that compiled the most relevant studies, which also showed that mature forest landscapes are the greatest storehouses of carbon of any land-based ecosystem. In temperate deciduous forests like ours, mature and old trees would naturally form 50 to 70% of a forest, mixed with younger trees that sprout in small, scattered openings formed by wind-thrown trees, the major form of natural disturbance, also ice storms and occasional lightning fires. A canopy with only small, scattered openings also discourages the many invasives like Japanese joint grass and tree of heaven that jump into sunny spots and suppress native plants. There's a structural complexity in layers of vegetation, including dead and down limbs and logs, that develops only over centuries, creating habitat niches that are unavailable anywhere else. These shelter complex living communities. Protecting existing forests so that they age naturally is one of the best ways to address the biodiversity crisis, with 1 million species now at risk of extinction around the world, mostly from habitat loss, because so many species use mature and old forests for some part of their life cycle. The cleanest waters ever tested flow out of undisturbed soil of old forests. In particular, the mycorrhizal fungi in the soil around roots are most abundant and diverse in old growth and are now thought to be a driver of carbon sequestration. Fungal networks, called the Wood Wide Web, absorb nitrogen and phosphorus from soil particles and exchange them for sugar in tree roots made by photosynthesis. Without the right fungus species, and there are millions of them, trees and many other plants simply will not thrive. So a lot of evidence is accumulating that the best way to sustain the ecosystem services that sustain us, the clean water, air, biodiversity, and now what we realize is essential carbon sequestration, is to mimic nature and allow forests to age in their own natural patterns. That's what carbon forestry is about. Logging is done less frequently to allow more trees to grow older, and is mostly based on careful thinnings that maintain the structure of the remaining forest. Because carbon forestry mimics natural processes and aims for the long-term future, it is highly conservative and the very definition of sustainable forestry. Now, there's a valid criticism of this approach that reducing the harvesting in one place could simply drive demand elsewhere, where forests aren't as well managed. The end goal has to be reducing consumption of forests. For example, an acre of hemp allegedly produces nearly 4 times as much fiber pulp for paper as an acre of trees. The first drafts of the Declaration of Independence and the Constitution were written on hemp paper, and the tents used by George Washington's army were made from hemp. It's now legal to grow hemp again, so there's hope. I'm an apocalyptimist, defined as an environmentalist who knows it's all going to hell, but still hopes it might turn out okay somehow. What carbon forestry is better suited for than ephemeral products like paper, and I include paper straws in that, is for what foresters call high-quality, durable wood products. The kind of furniture, for example, that might show up at a 22nd century Antiques Roadshow. This is said to be a way to keep tree carbon fixed long-term, and it is, until that furniture goes to the landfill, where the methane released may be worse than carbon dioxide. The use of engineered wood instead of steel and concrete, which emit huge amounts of CO2 during manufacture, can also retain forest carbon until those buildings are torn down as part of endless redevelopment. The newest use of forests is biofuel, supposedly just the limbs and tops left after logging, whose removal impoverishes the soil, but there's also no regulation to prevent wholesale clear-cutting and then developing the land, so forest never grows back to resequester the lost carbon. And even if forest does grow back, it will take a century to sequester the amount of carbon lost in a few hours of burning. And that's why planting new trees is wonderful and critical for many, many reasons, but sequestering carbon is not one of them, because that is so long-term that new trees really don't address the urgent need for immediate action. Protecting existing forests is what we need today. And that brings me back to existing forests in the Southern Alps. Most states in the upland South are more than 50% forested, and most of that forest land is owned by several million private owners. Although the recession of 2008 slowed things down, most states are losing thousands of acres every year to development. Losses are also ongoing as older forest owners die without estate plans, and the land is parceled out among heirs who bring roads, lights, houses, fences, pets, etc., which fragment the forest into ecological uselessness. In every state, the majority of owners own less than 50 acres of forest, and in some states it's less than 10 acres. So we're talking enormously fragmented ownership as well as fragmented forests. And yet, you obviously don't walk out of the global cycles of air, water, wildlife, and carbon when you cross a property line. While every state has a forestry department that offers advice and assistance, there's very little incentive for private forest owners to forego short-term income from logging, biofuel, or development for medical expenses, or a child's education, or just to pay the annual expenses of taxes, insurance, and maintaining roads. And southern states are notoriously averse to regulation, especially of private property. So the big climate question for the mother forest is, how can private owners be persuaded to practice long-term, sustainable carbon forestry? The idea of paying for ecosystem services has been around for years without much effect. There is, however, a huge worldwide carbon market that runs into the billions of dollars every year, and which includes the sale of forest carbon offsets to industries and utilities that emit CO2. Forest owners go through an inventory process that measures, certifies, and monitors the carbon in their forests. Some forest owners with a couple thousand acres or more are already doing this and earning pretty big bucks. But it's difficult for smaller acreages to overcome the inventory costs. A carbon broker told me that it would cost at least $50,000 to get my 112 acres onto a carbon registry. There are some organizations that are working on ways to bring smaller landowners into this market, which would drive the biggest forest conservation movement in history. But in the meantime, and it might be a very long meantime during which much more forest is lost, how can our forests best contribute to the stabilization of the global climate commons? The Weeks Act of 1911 authorized the U.S. Forest Service to purchase and repair millions of acres of burning, eroding mountainsides from willing sellers, largely timber companies that had exploited everything of value and no longer wanted to pay local property taxes. Ironically, the very destruction of the original mother forest has resulted today in 6 million acres in 8 nearly contiguous national forests down the highest Appalachian ridges, plus more distant units like the Daniel Boone in Kentucky. The 2 national parks comprise much less acreage, but the Great Smoky Mountains National Park is especially important for having the single largest stand of remnant original forest, around 100,000 acres. In the last 15 years, a research project there has identified over 1,000 species entirely new to science. This complex of public lands gives us something virtually unprecedented in history, that is, the creation of a commons after the land was exploited by private owners. The commons is another great undertold story, but I don't have time for that today. Although the Forest Service is not exactly progressive in addressing climate change, with plans for huge prescribed burns and quite a bit of logging, And although the Trump administration is trying to gut the National Environmental Policy Act, which gives the public the right to respond to Forest Service plans, nonetheless, the national forests present a much more cohesive and accessible target for immediate climate activism. And with many trees in the national forests about a century old, they are approaching their prime sequestration power. There are many organizations in Appalachia deeply concerned with environmental issues, so the activism base already exists. And some national forests have started stakeholders groups, which is a good way to access the Forest Service and other forest users. Who knows what collaborations might develop? Scientists around the world are saying that our future climate is inextricably tied to the future of our forests. The only realistic hope for the landscape-scale, long-term forest conservation required to immediately address climate change is the national forests. If public pressure induced the Forest Service to adopt conservative carbon forestry, mimicking old-growth structure and protecting soil from disturbance, this would pay reparations to the future for past destruction, while quite possibly saving our own skins. Thank you.